Rotating a linked list k times? Most people do it wrong, Mo. You don't need k loops, just one trick. Want full solution? Check this video.
Hi everyone and welcome back. Today we will solve the leetcode problem, rotate list. Imagine you have a linked list and you rotate it k times to the right. Sound simple? Yeah, but there is a trick that makes this problem super elegant. Today I'll show you how to solve this problem in O of n time and O of 1 space. This is the optimal solution. So we are given a linked list and a number k. Each rotation moves the last node to the front. So, for example, if we have this list, each rotation will move the last element to the front, and the second rotation will move the last element to the front, and so on and so forth. But instead of doing this k times, which would be slow, we need a smarter solution. So let's code it while explaining the solution. So first, we need to add some constraints, like we need to check if our head is empty or our head.next is empty, because this means that we have a single element. And if we have a single element, whatever the value of k, we will not do any rotation. And the last condition, if k equals 0, that means that we will not rotate our list. And all of these cases, we will return the head as it is. So the first step in our solution is to traverse the list to find its length. Let's name it n. So int n equal 1, and we will define a list node. Let's call it tail and assign it to head. So now we have a pointer to the first element of the list called tail, and we will iterate over the list. So while tail dot next not equal null. So in this case, we will advance our tail one position to the right, and we will increment our length variable n. And once we found the length of the list, we need to make it circular, which means that we need that the last element of the list to point to the first element in the list. So to do that, we will do as follows. So let's first name this as step 1, which is find the list length and its tail. Then we move to step 2, which is make the list circular, and this is by defining the tail dot next to point to the head. And but before that, let's name this step 3, and step 2 is to normalize the key value. Why we need this step? Because as you see here in example 2, that k is equal 4, which is greater than the length of the list. So we need to normalize this value of k. So k equal k mod n, and again if k equal 0, after this operation we will directly return the head. Then moving to step 4, which is finding the new tail. The new tail exists at, just name it, steps equal n minus k. So the new tail exists at n minus k steps. So again, in this example, we have n equal 5 and k equal 2, and that means that the new tail will exist after the third node. So again, we will define a list node. Let's call it new tail. And again, it points to the head node. And then we will iterate over the steps. And each time we will advance our new tail to the next element. After that, we move to step 5, which is breaking the circle and getting our new head. So again, we will define a new node, call it new head, and this will equal, as we reached here, our new tail. That means that the head will be directly one element after our new tail. So our new head will equal new tail dot next. Because again, for this example, our new tail will point to the node 3, and that means that our new head will be directly the node after it, which is 4. So the new tail will be node with the number 4. And finally, we need to reset the new tail pointer dot next to. So again, we have a node new head point to node 4, and we need to break the circle here. So we set the new tail to null pointer, and finally we need to return our new head. So let's run it to make sure that we need steps, I guess. Yes. Here we go, and let's submit it. And as you can see, it beats 100% of the solutions. So let's recap. To solve this problem, we need 5 steps. First one is finding the length. We iterate over the length to find we iterating over the list to find its length, and at the same time we keep track of the last node, the tail. After that, we try to optimize k, because rotating k times is the same as rotating k mod n times. So we reduce unnecessary rotation immediately. Then moving to step 3, which is making the list circular. So we connect the tail to the head, and that makes our list as a circle. And For step 4, we find the new tail, and to find the new tail, we move n minus k steps from the original head, and the node right after that becomes our new head. And finally, step 5 is to break the circle. Finally, we break the circle by setting the new tails next to null, and that's it. And we have our rotated list. We don't use any extra space, just one pass, clean and optimal. And that's it for today's solution. If you want more clean explanation like this, please subscribe to the channel and like the video for more videos like this. Thanks for watching and see you in next video.